Hi, in this video we will talk about launching a web application for predicting the lipophilicities of organic molecules from the model that we developed in this data science project. So this is how the app would look like, and it would have mainly two main pages, home page and about page. About page has information about this app and what lipophilicity is about and all other stuff, and home page is our main web page where you can put in smile strings for any molecule for which you want to predict lipophilicity wherever you are located. So I think this is really cool stuff. If you remember from our last video, we had this function, we defined this function predict underscore lipophilicity, which takes in list of smile strings, and it just gives the output in the form of numerical lipophilicity value. So we are going to be using the same function for developing a web application, but we need a server out there. So for that I'm using a Streamlit, and Streamlit is an amazing platform where you can deploy, manage and share your apps with the world directly from Streamlit, and all for free using Community Cloud. So that's what we are going to be using in today's lecture. So we have this function here, we have the platform Streamlit. So what I'm gonna do is I'm gonna take you to a folder which houses all the files which we need to launch a web application. So this is the folder Lipopred which has all the files. So let me talk about it one by one. So PyCache, it just houses some temporary files, so you can just put that as such. We don't need to put anything inside this folder. Resources file would house the model underscore lipo underscore tune.pth model that we saved after model training. So I have talked about that a couple of times in my previous videos. Then we have readme file, you can put in information if you want. Requirement store text file, so it has all the modules which we used for or which we are going to be using for launching a web application, for example Streamlit, right? So we are launching on a Streamlit platform, so we do need Streamlit. So we are using 1.36.0 version of Streamlit, and of course we are going to be needing RDKit, so that's over here. NumPy, you know, so all these libraries are in here. And then we have app.py file. So what I'm gonna do is I'm gonna be showing you this file over here, which is one of the most important files that we need to launch a web application. So I'm opening up a terminal here, and let me zoom in a bit. So what I'm gonna do is I'm gonna cd into this folder. So I'm into my Lipopred folder. Now the next step is create a virtual environment. So conda create -n. So I'm gonna name it Lipopred, and I wanna use a Python version of. So let me just take you back to the this predict from smiles method. So everything is in here which I've talked about in my previous video. It's just that I have imported this module session info, which would give me the modules and their version which we have used in Google Colab. So I've used 3.10.12 version of Python. So I just want to make sure I'm using the same Python version. So 3.10.12. So we have created the environment, and what next I'm gonna do is I'm gonna activate this environment. Okay, so this environment is activated. Let me clear out the screen. Okay, so Lipopred is activated. Now let's just open this folder in VS Code. So this folder Lipopred is open in VS Code, and I just want to talk mainly about this app.py file, which is the most important file. And let's just zoom in a bit. So of course we need torch, geometric, streamlit, and all these things here. If you look here, we have installed RDKit, torch, geometric, pandas, torch, and we have imported all these modules here. And then we just moved on to defining device, loading model, and putting it to evaluation mode and defining our function. And that's what is there in our app.py file. So after importing all these libraries, so from smiles method, Streamlit, of course we are going to be putting it on Streamlit, so we need to import Streamlit, and we are going to be using some of the methods from it. So this is the same, defining the device, loading the model, which is in our resources folder, so which I just showed you, and model.eval, and then this is the same function. So I have not changed anything except that in here, just to deal with exception, I have used exception as E. So if there is any error, so it will just throw this error here, so it would just in the end return predictions. So it is pretty much the same code. Now we need to basically work on the front end. So like I showed you in the web application, we need to have a navigation bar which would have home page and about page. So it would have a radio button. So if you click on the home radio button, it would take you to the home page, and if you click on the about radio button, it would take you to the about page. So this is the code here. If page is equal to home, so it will check if you have clicked on the home button, it would just take you to the home page which has all this information. So title is Lipophilicity predictions from smiles, and then some text, enter smile strings below. So these are the instructions, right? And then in the input area, so smiles input is equal to st.text area. So this function would put this smile strings one per line text above the area where we will input our smiles, and then we will have a predict button. So once you input the smile here, it would create a smiles list based on different lines. So let's say we put in 3 smile strings in 3 different lines, so it will create a list from that. And of course then we will call this predict_lipophilicity function for predicting the smiles here. So yeah, then we will just so this is again the same, we will just print out the lipophilicity values along with the smile string. So this is kind of the same code. I am zipping smiles and predictions, and then we will print these out using st.write function. And yeah, in the if we have a about page, if we click on the about page, it will check that if page equal to about, then it would just provide all this title about this app and all these text here. So yeah, that was just all about app.py file. And once we have this thing ready, we just check it locally. So to run this app locally on my computer, I need to install all the dependencies in my virtual environment. So let me again just take you to the terminal here. So this is the requirement.txt file which houses all the modules and dependencies. So what I'm gonna do is pip install -r. So it has started installing all the dependencies. Okay, so I think it has installed all the dependencies which we need to run it locally. Let me just clear out the screen, and now if everything is all right, all we need is streamlit run app.py. So it should open in Chrome. So it's running. Okay, so I think we have successfully launched the web application on our computer. If there are any errors, they will show up in here, but I think for now we are good to go. So yeah, we have the home page which has some text, lipophilicity prediction from smiles. So this is the header, some instructions, then it's asking for smile string. So let's see if it works. So I am just opening up my camera. So these are the same molecules that we used for predictions in the last lecture. So again, in here for the phenolic or OH containing molecule, we had less lipophilicity value of 0.2754, and for that carbon hydrogen containing molecule, just we had a little higher, 4.12. So I'm gonna be using the same two molecule just to see if it matches. So edit, copy as smiles, and then just go to our web application here. So this is the alcoholic molecule, and then just the hydrocarbon. So let's predict. It's running. Okay, so we have got the predictions. For this molecule it's 0.2754, and for the second molecule we have 4.12. so it's pretty much the same. So yeah, so this is how you can deploy it in your computer. Now we want to launch it on a server, on a Streamlit server, so on a cloud platform. So what we need to do is first, so I'm on my GitHub repository here. So what I'm gonna do is I'm gonna go here, I'm gonna go to my repositories and new repository. So just name it as Lipopred, and yeah, we wanna make it public. We can just add readme, it will just overwrite, and now we'll just drop the files here. So this is the folder, right? So we are gonna be just dropping all these files here. Now there is just one file that I wanna talk about. So we have app.py readme requirements.txt resources folder with our model. There is one more folder here which is .streamlit. It has configuration file which is named as config.toml. Now the GitHub recognizes this as a hidden file, so it does not uploads it. So what I'm gonna do is I'm just gonna make a folder. After I've committed it, I'm just gonna create a new file and name it .streamlit config.toml. Now I'm just gonna copy and paste here that file content. It just has theme for, so you have light here, you can put it as dark as well. Okay, so commit changes. Okay, so this is the Lipopred folder on my GitHub repo, and all these files are here which we need to launch a web application. Now I'm gonna go to the Streamlit platform here, and I'm gonna sign in using my GitHub. So what we are gonna do is create app. Yes, I have an app. Now we need to put in the repository name, so code. So we are gonna be finding it here, Lipopred here. Yeah, so our app name is app.py, and we can give it a name as Lipopred. Yeah, it's available. So it would be lipopred.streamlit.app, and just deploy. So it's processing. Okay, so it has been successfully launched, and just I wanna make sure it's predicting right. So just copy this, copy these smile strings one more time and paste it here. Yeah, so it's working. So you can access this app using this link. I will provide you this link in the description. And yeah, this is how you can just launch a web application for a model that you have developed and just showcase your results. So yeah, that was it about this video. Thank you for watching.